Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12. We are doing chapter number 5 of class 12, that is continuity and differentiability. And as you can see in your title, we are doing exercise 5.2 of this chapter, and we are doing each and every question of this exercise. In this video, we will do question number 4 and 5 of this exercise. Let's begin this video. Okay, so what we have to do, like we have to differentiate the function with respect to x. Okay, we have to differentiate our function with respect to x. So this is our question number 4. So our function, let's say this is our, name this function as f of x. So our function is defined like this. Okay, so I have already told you in my previous lecture also, or if I want to like explain it more, that what, sorry, tell you what I told in my previous lecture is that this type of questions where you have to find the differentiation by using the chain rule are very important. If I mark it as an important, so this type of questions are very important for boards, because here what you have to do, you just simply have to find the differentiation, but you have to use your chain rule, for which, like, board's favorite question, like using a chain rule, use applying a chain rule by composition of function is very important for you guys. You should understand that. How should we do that? Okay, so in previous lecture, in previous video also you have seen where in question number 1, 2 and 3 you have to just use the composition till 2. You have to make a use of, there is use of only two functions composition, but now you can see here you have to use three functions composition. Okay, so what I have told you, always take your outer function as first, that is w of s. Take it as w of s. So take your w of s is nothing but your sec s. Now the another is tan function. So take your b of t as tan t. Then the last one is nothing but your root x. So take your u of x is nothing but root x. Now, as you can see from this, your W composition with U, V composition with U of x is nothing but it will comes out to be W of V of U of x, that you can see that is nothing but W composition of V of root x, because U of x is nothing but root x. Then here it, from here you can see your t is nothing but your root x, because we have to make v of t. So now from here v of root x is nothing but tan of root x. Then your tan of root x, w of tan of root x is nothing but sec of tan of root x, that we have to, like, that is nothing but our f of x function. Okay, its differentiation we have to find. So from here you can see, so our t is from here you can see our t is nothing but u of x, that is nothing but our root x. So take it as 1. Then from here you can see we have w of s. So you can see your s is nothing but tan of root x. Your s is nothing but, as you can see, this is nothing but your s is nothing but, because we are taking it, sorry, this is our s, right? This is our s, that is v of t. V of, like this here I am using root x, but actually it is v function, that, and v is given, v is given in terms of t, that is nothing but v of t. Okay, and our v of t, as you know, that this is nothing but tan t. So take it as 2. Now let's find its differentiation. I have told you how we have to apply our chain rule. If we have to find dv by dx, because we have to differentiate our function with respect to x, then by using chain rule, what we have, we have to differentiate our outer first, that is dw, and we have to, as you can see, it is in terms of s, so we have to differentiate it with respect to s. Then differentiate your s with respect to, it is in terms of t. As you can see, s is in terms of t. Then after that, as you can see, your t, differentiating t, as you can see, your t is nothing but a ux. So ux is, so it should be differentiated with respect to x only. Okay, now what I am, like, I am giving you a hint also, or maybe you have, like, if you know how to use chain rule properly, you also have come to this point, but I'm giving you as a trick. Suppose if you have to find df by dx, start with your outer, then the dw, it is differentiating by x, then x differentiate by the another which in which your s is in depending on, that is t, then your dt with respect to where it is depending, your t is like this t function is depending on x, so dx. As you can see, if this cancel out, at the end you come to find your what is your df by dx. Okay, now let's find it. So we know that this is standard differentiation. We have to differentiating x. We know that differentiation of course sec x is nothing but sec x 10 sec is nothing but sec x 10x. So here it is sec s 10s. Then now differentiating s with respect to t. Our s is nothing but 10t. So we know that differentiation of 10 is nothing but sec square. So this is sec square of t. Now differentiating t with respect to x. So our t is nothing but root x. So it's differentiation because x raised to n differentiation is taking n out, that is half x raised to half minus 1, that is nothing but minus half. So if we like simplify it, so it will be sec, put the value of s. So as you can see, our s is nothing but 10 t, and put the value of t again here. So our 10 is nothing but root x. So this is sec 10 of root x multi 10 of root x, then sec square of t, putting the value of t, our t is nothing but 10 of, our t is nothing but root x, so this will be sec square of root x, then half of root x. So this is our differentiation, right? So as you can see, this is our differentiation. May I check it? So this is the sec with 10, right? Root x, then sec x 10x 10 of root x, then the differentiation of 10, that is sec square, then differentiation of root x. Yeah, we are done. So if I want to like write it in the proper manner, so our df by dx is nothing but sec of 10 root x multi 10 of 10 root x multi sec square of root x multi divided by, because 2 root x. So this is our df by dx. If I like, if you think this is like very lengthy to find the differentiation in chain rule, what I'm giving you a hint is, so find your outer differentiation, that is sec x differentiation. We know that our sec x differentiation is uh, should I write? Yeah, I will write it here. So our sec theta, its differentiation is nothing but, sorry, sec x. If I like if you confused with the theta and x, I will make my variable as x only. So if you know that sec x differentiation is nothing but sec x 10x. So now what we have to do? So differentiating the outer constant sec, put your like inside value as it is. So it will be sec sec with inside value this, then sec x 10x, right? So 10 with inside value this. Now differentiate the inner one in the product. Like continue in the product till you get in the end of the inner function. So what we have find so what we have, like first we differentiate sec, so write it as it is. Okay, so sec, write as it is, that is sec x 10x, right? 10, write it as it is. Then now it's done, like outer differentiation is finished. Now let's move to the another inner one. So inner is 10x, so differentiation of 10x is, we know that sec square x. So sec square, put the inner value as it is. Okay, then this part is done. Now move to the another inner, because another inner point is there. So root x differentiation. We know that root x differentiation, put this differentiation as it is in multiplication. So this is 2 root x. Okay, then there is no one, like no another in inside. So we are done. This is our differentiation. I just give you the like direct if you want to guess what is your differentiation. Otherwise, go with the chain rule. You will never make a mistake. But in this case, what I'm explaining you in a trick, maybe sometime you make mistakes. So it's like if you are very smart, you can like think it directly, then go with this trick. Otherwise, welcome to our chain rule proper method. Okay. So now we are done with this question. Let's move to the next question. So next question is question number 5. So here we have, this is our f of x. We have to find its differentiation. As you can see here, you can easily apply whenever you have a function. So in which you have suppose say v of x by u of x form. Always use your differentiation, like a quotient rule of the derivative. Okay, we know that it's quotient rule. Its derivative is given by v dash u minus v u dash divided by u square. So we're gonna you would apply this only. So for that, so what is our f of x is v of x divided by u of x. Our from here, as you can see, our v of x is nothing but sine of ax plus b, and our u of x is nothing but cos of cx plus v. Now what we do, we find its differentiation, we what we have to put in this formula, right? Just put the value. For that we need only to find our v dash and u dash. So I am writing your v dash and u dash directly because it's the same in we did in the previous also. Just have to apply the chain rule. So if I want to like explain you this part in short, I can, but I am sure that you will like know this thing still now. So this for derivative v dash of x, we have to find the derivative of sine ax plus b. So for that we have our outer function is sine x, so we have to differentiate our sine. We always take our outer function in terms of t, sine t with dt, then differentiate the inner function, that is t function, that is nothing but here our t is nothing but ax plus b divided by sorry, differentiate with respect to dx. So this will be differentiation of sine t is nothing but cos t, and differentiation of this is nothing but a, right? So this will be a cos, put the value of t is nothing but ax plus b. So this is its differentiation. I'm just writing it directly. Write the outer differentiation first, that is nothing but cos. Put the inner value as it is, that is ax plus b. Now differentiate the inner part in the multiplication. So differentiation of inner part is nothing but a. Now similarly this part. So this is cos. Cross differentiation is nothing but we only, these are the standard differentiation. You can easily find it this in books, and I have already told you this in my introduction lecture also. If you are not watched that video, you can see in your textbook, that is maybe in table number 5.3, you can see your standard differentiation. Okay, so cos x differentiation is nothing but minus sign. Put the inner value as it is. Now find the differentiation of inner one in the multiplication, and we know that cx plus b differentiation is nothing but c. Okay, now we have find, this is our v dash, this is our u dash. Now what we have to do, we have to just put the values in this. So our derivative of f dash of x is nothing but v dash is nothing but cos ax plus b, multiply with a, then multiply with u, that is cos of cx plus d, minus v, that is sine of ax plus b, multi u dash, that is nothing but minus sine of cx plus b multi c, whole divided by u square, that is nothing but cos cx plus d whole square. Okay, So this is, if like I have used V by U, but it's fine, right? You have learned your formula by using U by V rule, but same, just interchange the variables. Both are same. Like take V by U or U by V, just like it will work as same. No, doesn't matter. The name of the variable doesn't matter. So this will be A of cos AX plus B. Just I am simplifying it. So this will be cos of Cx plus D minus, and this minus will be plus sine of Ax plus B multi this, take the constant in the beginning, right? Always write the constant in the first. So this is sine of Cx plus B divided by cos of Cx plus D whole square. Okay, if you want to write it in 10 form also, if you can, but I don't think there is a need. You can like stop yourself till here also. But if you want to move one step further, I can write for you. That is your f dash of x is nothing but a cos ax plus b divided by cos cx plus d cx plus d plus c sine c sine ax plus b multi that sine cx plus b divided by cos cx plus b. This is nothing but 10. So this will be 10 cx plus d divided by one more cos left, that is cos cx plus d. So this is our f dash of x. If you don't want your cos in the denominator also, you can convert it to sec also, but it's fine. Like I have did this as a further step also. You can like stop yourself till here also. Like just find your v dash, find your u dash, and put in the like quotient differentiation form. Nothing different, nothing hard in that. Okay, so we are done this question. That's all for today's video. Please do this questions once by yourself. And if you have any doubt, just ask me in the comment section and I will try to solve your doubts as soon as possible. And please like, share, and subscribe this videos so that this videos can reach you as per you want. That's maybe that will be helpful for you because you are getting the solutions of each and every questions. Or then let's meet in the next video. Then please like, share, and subscribe. Thank you.